Hey everyone, it's Betsy here, and today we are going to do a review of functions. So let's take a look at the first one. We're giving a mapping with our inputs and our outputs. Remember, our inputs are our x coordinates and our outputs are our y coordinates. So the input is also the domain and the output is the range. So what is a function? Remember, to be a function, every input has to have a unique output. So for every x, there has to be a unique y value. So take a look at the first one here. I'm going to write it out as order pairs so we can look at it. 0 goes to 9. 0, 9. 4 goes to -2. So 4, the input is 4, the output is -2. 6 is the input, 7 is the output. And then for 7, 7 is the input, and 5 is the output, but also when 7 is the input, 9 is the output. So we can see here that this 7, this input, goes to two different outputs, here and here. Therefore, this is not a function. Let's take a look at this set of ordered pairs here. When I look at your x values. If they're all different, it's automatically a function. But if they're not all different, then you need to look at the y values. So here I've got a -7 and a -7. So now look at the y values. Are they different? No, they're the same y value. So yes, this is a function. When I look at the next one, again, look at the x values. If you have two x values that are the same, then you need to look at the y values. If they're not the same, it's not a function. No. And finally, when I look at the next one, let's look at our x values. My x values are all different, so yes, this is a function. Yes. Same x, different y, no. Same x with a different y. That's the only time it's going to be a no. Let's take a look at the next one. We have a graph. So ding, 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 ding. Right away, you should be thinking, let's do the vertical line test. So when I draw a vertical line through the dots, does the vertical line cross more than one dot? Well, right here it does. It crosses more than one. Therefore, this is not a function. To be a function, every time you draw a vertical line, it can only cross one time. So that is not a function. And that's your goal. Your goal is to try to make that vertical line cross more than once. If you make it happen even one time in your drawing, it's not a function. All right, let's go on to our next page here. So let me put up the next page. On this page, we're going to take a look at domain and range. So we're going to look at our domain and range. And remember, your domain is how far over it goes left and right. Your range is how high and low the drawing goes. When I look at this first drawing here, this is a discrete graph. It has dots, they jump. So when you have a discrete graph, you've got to list the x coordinates and list the y coordinates for the domain and range. So my domain are my x coordinates. So let's take a look here. 1, 2, 3, 4, 5, 6. -6. Let's try to do them in order. 1, 2, 3, -3, -1, -2. Then I've got over 1. And I've got over 1, 2, 3. And over 1, 2, 3, 4, 5. So those are my domains. Those are the x coordinates for each of the points. Now the range are our y coordinates. So the lowest y value is right here. So I'm going to see how far down that is. 1, 2, 3, 4, 5, 6, 7 down. So -7. The next lowest is right here. How many down is that? 1, 2, 3, 4, 5 down. Our next lowest is right here. How many down is that? 1, 2 down. Our next lowest is right here, which is 1 above. And then our next is here, which is 2 above. And finally, our last one is 1, 2, 3, 4, 5, 6 above. So that's my domain and range for that drawing. And would that be a function? Yes. If you do the vertical line test, it's only going to cross each point one time. All right, let's look at the domain and range for the next one. So we'll start with domain. How far over does it go? So the domain, we're looking at the x values. So the farthest point over is right here, and then it goes on forever in the other direction. So my domain is from 1, 2, 3, 4, 5, 6, -6. And it's open, so I'm going to use a less than sign. If it was closed, I'd use a less than an equal sign. So we're not including the -6. X is our domain, which is less than. It continues on forever, so it goes to positive infinity. And when you use infinity, you always leave it as less than, not less than or equal to. If I wanted to write that as an interval using brackets and parentheses, it's open on the 6 and it's open on the infinity. So it'll look like that. Now your range. How high and low does the graph go? Well, the lowest point is right here. And again, the highest point, it goes on and on. So lowest point is 1, 2, 3, 4, 5, 6 again. So -6, and it's open, is less than y. Y is range, which is less than infinity, because it keeps going up. And if I want to write that using parentheses, it's from -6 to infinity. Let's take a look at our last one here. So the domain, how far left and right does it go? We'll put it right here and right here. So from 0, I got 1, 2, 3, 4, 5, 6, 7, 8, 9. So -9, and it's closed on the -9, so I'm going to use the less than or equal to. Domain is x. Now it's open on the other side, so I'm going to use just a less than symbol. And it's 1, 2, 3, 4, 5, 6, 7, 8 on the other side. If you want to write this using intervals and brackets, it's closed on the -9 and it's open on the 8. Now let's take a look at how high and low it goes. The lowest point seems to be right here, and the highest point is right there. So 1, 2, 3, 4, 5 below. So -5, and that's closed. There's no open circle there. We're talking about range, which is y. And the highest point is 1, 2, 3, 4, 5, 6. But again, that's open, so I'm going to use a less than symbol. I'm not including the 6. So if I want to write it using parentheses and brackets, it's closed on -5, but it's open on the 6. All right, so just remember domain and range left to right. Range, or the domain is left to right, the range is how high and low. All right. Now let's evaluate some functions. So let's take a look at the first one. Remember, the reason for naming these functions using different variables is that you can distinguish between them. The first one is f of x equals -2 times x plus 1. G of x equals x cubed minus 4. And h of x equals 5 minus x. In the first one here, h of -3, they're telling you to replace x with -3. So when I go over to the h of x function, wherever I see an x, I'm going to put -3. So I have 5 minus x, which is -3. And that double negative makes a plus. 5 plus 3 is 8. Watch that. This minus is right here. But then you have to put -3 in for x. If it helps you, you can do this. Put a box around the x, and you're replacing x with this. So if that helps you use boxes, use boxes. All right, now let's do f of 4. So instead of x, I've got a 4. So wherever I see an x, I'm going to put a 4. Again, if you want to use a box, you can. -2 times x, which is 4, plus 1. Well, negative times a positive is a negative. 2 times 4 is 8, plus 1. That gives you -7. Now, g of -2. So now we're replacing x with -2. So here's my x. I'm going to replace that with -2. And I've got to cube that, -4. Well, -2 times -2 times -2 is -8. So then I have -8 minus 4, which is 8 negatives and 4 negatives gives me 12 negatives. So let's go back to the first one again. When you input -3, your output is 8. And number 2, when you input 4, your output is -7. And the last one here, when you input -2, your output is -12. All right, let's go on. Now, first of all, let's erase this, clean these up a little here. All right. So in the first one here, they want us to replace x with m plus 1. So I'm using the f function, so I'm over here, and I'm replacing wherever I see an x, I'm going to put m plus 1. So it's -2 times x. Well, x is m plus 1. And then I've got to still add 1. So I put m plus 1 in for x. And I got to do -2 times that. So you got to distribute this -2 through the parentheses. A negative times a positive is a negative. 2 times m is 2m. A negative times a positive is a negative. 2 times 1 is 2. And we still have this plus 1 sitting here. Now, if you remember like terms, if one of the terms has an m in it, to be like another term would have to have an m in it. We don't have that. So bring down your -2m. And then you got a -2 and a +1. If you add those, you're going to get -1. And that's your answer. So if you input m plus 1, your output is going to be -2m minus 1. That's what that tells you. All right, let's take a look at the next one. We want to replace x with 3a. I'm replacing x with 3a. So wherever I see an x right here, I'm going to replace it with 3a. Why am I using this function? Because it's h. That's how I know to use that function. So now I have 5 minus x. Well, x is 3a. And those aren't like terms, so that's all I can do. So when I input 3a, my output is 5 minus 3a. All right. Let's take a look at the last one. C here. I'm going to change the color. Let's go with this color. All right. We're looking at the g function. G. We're changing x to c. So we're inputting c for x. So wherever I see an x, I'm going to put a c. So I've got x cubed. Now I have c cubed. And then minus 4. I can't combine those because they're not like terms. So when I input c, my output is c cubed minus 4. And we're done. Ta-da! I hope this review helped. If you have any questions, just leave them in the comments and I'll gladly answer them. Have an awesome day. La 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 la.